The ocean covers more than 70% of Earth's surface. But have you ever wondered why it's salty? Rivers aren't salty. Rain isn't salty. Even glaciers are made of fresh water. So how did our oceans become giant basins filled with minerals? Today, we dive into the real science behind Earth's salty waters. A story billions of years in the making. When Earth first formed, its oceans were not salty at all. Early volcanic eruptions released enormous amounts of water vapor. As the planet cooled, this vapor condensed into rain, falling non-stop for millions of years, filling the basins that would become our oceans. At this point, the water was mostly fresh. So where did the salt come from? The answer begins on land. Every raindrop that falls on Earth slowly erodes the rocks it touches. This erosion breaks down minerals, tiny bits of elements like sodium, calcium, and magnesium. Rivers carry these dissolved minerals toward the ocean. Most of the visible sediment settles before reaching the sea, but the dissolved minerals remain in the water. And once they arrive in the ocean, something important happens. They don't leave. When ocean water evaporates, forming clouds and eventually rain, the salt stays behind. Only the water molecules rise into the atmosphere, so the minerals accumulate, slowly increasing the ocean's salinity over hundreds of millions of years. Today, if you took all the dissolved salts from Earth's oceans, you could cover the entire planet with a layer of salt more than 150 meters thick. If rivers constantly bring new minerals into the ocean, why isn't the ocean becoming saltier every year? The reason is balance. Salt is removed from seawater through several natural processes. Marine organisms use minerals to build shells and skeletons. Underwater hydrothermal vents trap minerals in newly formed rocks. Salt can crystallize and settle on the seafloor. These processes remove almost as much salt as rivers bring in, keeping ocean salinity stable at around 3.5%. Some waters are much saltier than others. The Dead Sea, for example, is so salty you can float without trying. Meanwhile, the Arctic Ocean has lower salinity because melting ice adds fresh water. Climate, evaporation, rainfall, and ice all influence local salt levels, creating oceans that taste and behave very differently. Ocean salinity isn't just a chemical detail. It's essential for life on Earth. It helps control global ocean currents, influencing climate patterns across the planet. It shapes marine ecosystems, affects buoyancy, and even helps regulate temperatures. Without salt, our oceans and our world would function in a completely different way. So the next time you taste the ocean's salt, remember, it's the result of billions of years of Earth's geology, chemistry, and water cycle working together. If you enjoy learning how our planet works, Make sure to subscribe for more Science Unlocked.